Hello everyone. Uh, this is the research video represented by Dongkan Hu, Zhongda Wang, and Keda Li. Because we three are not actually meet together, and we just do this on the Google Drive, and I will be making this video representing this to you guys. And the topic is hydroelectric. First, comes out in our mind is the dam, which is a perfect example of the hydroelectric. And we at first we should know how it works. How do we get energy from it? Because the dam is producing so much electric energy, powering the families and firms. Um, as we all know, the this is a theory based on the conservation of energy, because the energy can be transferred and the total amount of energy would not change. So as we look here, when the door is closed, the higher level dam, a higher level river will contain massive potential energy, and when the door is open, the river will force down, and the potential energy will transfer into the connecting energy, and letting the generator move to generating the electric power, and this is how it works. However, we have fish passage problem because when the higher level river comes down, the fish will also come down, and this will seriously break the environment of the upper level river, because there's some fish called migratory fish. It's a form of fish that has evolved over the long term, and many species migrate cyclically in different waters. However, human activities such as the construction of water conservancy well and the hydropower projects has crudely cut off the routes of the migrates of fish. And there's an example like Han River fish near the power station will be robbed because the fish come down with the higher level river water, and this may cause the extinction of rare fish. So we should construct like a circle to solve the fish passage problem. So here comes the solution. Like we can build a adult fish ladder. It allows the adult fish like come through this circle to come back to their original state. And about the juvenile fish, we just use mankind power to like catch it and use boat to release them into the original river. Yeah, and this is how we do this. Here comes the specific example of hydroelectric dam, the Three Gorges Dam in China, and we will discuss the existing problems and for four parts: the technology and environment and the society and architecture. First, we got technology. It's the long distance power transmission, and it's like the energy loss caused the low efficiency of electricity. So Three Gorges project is located in the upper reaches of Yangtze River. It is necessary to use long-distance transmission of power. The energy loss mainly in transmission line due to the generated thermal effects of current. So how do we decrease the loss of energy? Since R equals to rho L divided by S, we know that the distance is constant, so we should choose the wire that with small resistance rho and the large cross-sectional area. And furthermore, as the P equals to Ui, to ensure that the output power P unchanged by increasing the voltage and decrease current to take high voltage transmission. Also, according to the Q equals to I square RT, we can see that under the condition of the same resistance, when the current is smaller, the loss of an electric energy will be smaller. And then we will discuss the environmental impact. We got advantages like the Three Gorges high power project generates 847 multiple 10A kilowatts per hours per year. Compared with the thermal power, the less burn the 5,000 multiple 10 for T of the raw coal can be effectively reduce the pollution of the surrounding environment. So it's like environment friendly and less emission of the carbon dioxide, sulfur dioxide, and carbon monoxide and ammonia, as well as the large amount of wastewater, were also reduced and avoid each year. However, there is also disadvantages too, like the Three Gorges project can also significantly increase the flow in the dry season in the middle and lower reaches of the Yangtze River. And this is conducive to the safety of the rare animals and other fishes overwintering and reduce the time in Shanghai to eat salt water. And furthermore, there's also a disadvantage like in February 2008, the State Environmental Protection Administration said that some of the tributaries of the Three Gorges Reservoir area are partially eutrophic. According to the analysis of the chain of the water quality has been improved under the premise of maintaining stability. However, the partial water area and the water bloom occurred in some tributaries of the reservoir area. The quality is affected, which poses a threat to the drinking water safety of the local people. And we have one more, like the Three Gorges Dam changed the climate in the surrounding area. Because the high temperature, because of the high temperature in Chongqing is a typical example. As 2006, there's like 9 districts and countries in Chongqing suffered different level of disaster. And the reservoir dried up in the whole city. So the dam is like seriously affected by the temperature of the surrounding area. We have also society problems. The Three Gorges Dam will exacerbate the conflict in the reservoir area, which much more people live in the less space. Because the dam is so big and will cause deforestation and land reclamation on the large scale problem. And this is the society problems. And we have also artifactual innovations. Like the first is closure and the deep water cover dam technology. In the process of the river closure, the significant problems are large flow, deep water, and severe slump of embankment head. And the second is STEM concrete construction technology. In order to ensure the project's quality and the construction period, a rapid construction of concrete technology was found. And the third is the design and the manufacture installation technology of hydro generator. Applied the new generation of the hydraulic turbine, the stator winding installation, generator, air cooled, and the evaporative cooling of the core technology. And here comes our reference to the data we got from the website, as you can know here. And that's all. Thank you for watching.